Hi everyone! If you're new here, we're working on a traffic simulation game that will one day transition into a modern city builder. It's been a while since the last devlog, sorry about that. We've been busy working on vehicle intelligence, or lack thereof. First of all, we want to stress that everything that moves or changes in any way during the simulation is multi-threaded, burst compiled, and optimized for efficient memory access, thanks to Unity's entity component system, so the game will take full advantage of your CPU. There's so much information packed into this video that we've split it into chapters. We'll be talking about basic movement, collisions, crosswalks, merging, lane changing, lane sorting, lane rating, pathfinding, congestion, A-star algorithm, trailers, trailer lane changing, Megatram, and middle connections. This video is the culmination of 4 months of programming during which my sanity slowly declined, just as it did by the end of this video. And if you get to the end, there will be additional sneak peeks. So, enjoy the mayhem. So the first thing we had to do was change vehicle movement, and for that purpose we've created this test track. It includes some unrealistic curves such as this one, and also extreme tilt and curve like this one. Previously we simulated vehicles with a single point in the center, which didn't work at sharp curves or uneven surfaces. Therefore we moved the simulation to the front axle and added as many rear axles as necessary, in this case 1. Thanks to this improvement, vehicles have no longer any trouble navigating even the most unhinged of paths. And also speed bumps will be easily simulated. The lines and circles displayed on the road are representing various debug information such as curve, rotation and tilt. Here's the same route with a fully rendered 3D model. Going up this hill isn't perfect, but that's what you get for being a bad engineer. And because we want to simulate potentially tens of thousands of vehicles, we can't afford to use a physics engine. The entire simulation is just a few basic math equations. And before anybody says anything, I know that a physics engine is basically a set of math equations. But you know what I mean. This is why there are small artifacts on extreme surfaces, because using raycasts would be too easy. Trams can navigate the same path too, although as you can see the little guy is struggling a bit. Still smoother than public transport in my city though. Another thing we implemented is speed and the effect the environment has on it. Here we have a stretch of road with a speed limit of 50, variable lane width and some trees. So let's see how a car behaves here. On the right here you can see its current speed. So right off the bat you can see it's going a bit higher than the speed limit because that's what the personality of the driver is. Let's unpause the simulation and see what happens once it reaches those trees. So as you can see the vehicle slowed down. That's because large objects such as trees can be used as traffic calming measures. People tend to naturally slow down when visibility decreases. On the other hand, when lanes become too wide, people tend to speed up, in this case quite significantly. But adding the trees back will make the vehicle slow down again. Although with very wide lanes the returns are diminished. And since every driver has a different personality, they're not affected the same way. Some are even completely unaffected by their surroundings. Also, as a matter of course, vehicles will automatically slow down before a curve. Let's move on to collisions. First we had to rework how vehicles are registered on a path. Instead of spatial calculations, we now use a single number to represent the current distance traveled on a given path. Thanks to this we can easily find the vehicle ahead and our distance to it, which is in this case around 17 meters. Also, this is a slow motion. Collisions are updated every quarter of a second, which saves quite a bit of performance. This has a small downside though, which is that at sharp curves the distance might be off a bit. That's why at under 10 meters the calculations switch to spatial. Every time a vehicle has an obstacle ahead, such as this traffic light, it'll calculate the trailing distance range and try to slow down or stop accordingly. Right on the spot. We've also updated the crosswalk logic so that vehicles yielding to pedestrians will start moving as soon as their lane is cleared, as compared to waiting till the entire crossing is empty. That of course also works with bikes. Let's take a look at merging. Here you can see that the vehicles on the left have to yield to vehicles on the right. This works most of the time, but sometimes you want a zipper merge. So that's what we did. It's not perfect, but as it is with everything showcased here, it'll probably be improved upon during the early access stage. Alright, let's talk about lane changes. Vehicles will no longer change lanes as quickly as if Jesus took the wheel. But they will actually take their time based on their speed and available distance. As you can see here, this bus took its sweet time, but not as much as to block the other lane. Also, if the bottom lane was full, the purple bus would have continued up until this point, where it would then force a lane change. If you wanted to change this behavior, you could always add a solid line, for example, here, and try again. This time the bus was forced to make a quicker lane change. This also works the other way around when the vehicle is leaving a congested lane. These calculations leave so little room for error that all we need is Jean-Claude Van Damme on top of the grid bus and this shot would be perfect. Of course I had to use a console command to disable brakes there because normally the buses will create space between them like this. Here's another example of lane change, this time to overtake a slower vehicle. But that's not even the best part. The vehicle will actually return to the rightmost lane as is the law in most of Europe, even on 3-lane highways. I know, zero realism, but a person can dream, right? You can of course toggle this behavior per road segment. Another cool feature are merge lanes. Vehicles will try to leave these in the direction of the arrows painted on the asphalt as soon as the neighboring lane is free. In case it isn't, they will continue as far as possible and merge at the end. Every BMW driver is forced to drive through this map 10,000 times and each time they forget to use their indicators, the counter is reset. Let's look at lane sorting now. When a path splits into multiple valid alternatives, the pathfinding algorithm will try to semi-randomly select one of them, although the shortest one still has the highest chance. Now let's see how it looks when there's a traffic light at the end. I'd say this is a pretty good lane utilization. Let's watch a longer alternative with additional solid line markings. I honestly think the throughput is solid, at least compared to what it used to be. So here's the issue with choosing lanes randomly. Sometimes you don't want to do that. If a vehicle is going from the bottom left to the top right, ideally it would choose the leftmost lane. Always. So let's see what happens. Works like a charm. And this is a great segue to the next chapter, which is lane rating. So if a vehicle wants to turn right at this intersection, it can of course use all of these 3 lanes, but the smartest thing to do would be to choose the rightmost lane as soon as possible. This is where lane rating comes in. So let's start the simulation. When a vehicle approaches an intersection, it uses 2 of our very own super duper ultra cool algorithms to calculate 2 ratings for each lane ahead. These ratings are then combined and used to trigger a lane change where possible. So let's see if it works. Yay! This also applies to the intersection pathfinding algorithm. So if a vehicle is coming from the left and going to the right, it should choose one of these 2 lanes because these 2 are going to the right. Right? Wrong. And that's because if we look a little further, we can see that only the left lane is going in the right direction. So ideally, the vehicle would choose this lane. Now let's see what happens. Awesome! And just that you see that this wasn't a fluke, I can run it as many times as I want. One thing about lane rating is that it looks 5 intersection nodes ahead. This can be decreased if you want dumber drivers or increased if you want omnipotent ones. Or, and here's a great idea, it could be tied to the driver's personality. Looks like these devlogs aren't useless after all. Pathfinding itself is another completely reworked feature. So as you can see here, you have a large incline and a smaller incline. I think you can guess where this is going. So when I start the simulation, the bigger vehicles that can't make the large incline will choose the detour, while smaller vehicles will choose the shortest path. The same applies for lane width. So here we have a very narrow road, and when we start the simulation we can see that all the large vehicles again are choosing the long way around just because they can't fit on the narrow street. Unfortunately there's a width limit, so your mama will accept maximum incline and minimum width. Pathfinding also takes into account maximum turning radius, maximum height clearance under bridges and within tunnels, maximum weight for bridges, and minimum speed, for example on highways, so no tractors there. Additionally, it also applies malus to surfaces such as gravel and prefers roads with more lanes and higher speeds. And most importantly, it also detects congestion. Once a path becomes congested, vehicles will try to find a way around. The game calculates average congestion for the last 2 seconds, 10 seconds, 1 minute and 5 minutes, and uses them where appropriate. Congestion is also taken into account when pathfinding within an intersection node. So let's assume our traffic lights are set up like this and start the simulation. So as you can see, vehicles tend to choose lanes that move the fastest, but it takes a while for the average speed to be updated and reflected into the pathfinding result. It's not perfect and it'll probably need more work in the future, but at the same time these traffic lights are punishing drivers in the rightmost lanes for no reason, so it's a very unrealistic scenario. Vehicles will also repathfind upon encountering a traffic jam, which adds another layer of realism. They also have a patience factor, which consistently decreases when they're not moving. The less patient they are, the more likely they are to prefer uncongested routes. As you can see, some of them have already taken the detour. So even though the entire pathfinding is calculated immediately when spawned, it can be recalculated many times during the simulation. Let's check out how the A-star pathfinding works within an intersection. Here's a version of the magic roundabout in Swindon. Say we want to go from here to here. By pressing my mouse, you can see each step the algorithm takes. Only vehicles use this algorithm during simulation. Pedestrians and bikes use a cached version because they don't care about congestion. The green line is the resulting path. A similar algorithm is used for overall pathfinding. Here we have a large interchange from the announcement trailer. Let me turn on the node overlay. So here's the navigation graph for this single interchange. Imagine what it would look like for the whole city. Oh my god, I just realized we will have to optimize even the debug tools, because a huge city would not survive this overlay. So let's say we want to go from here up to here. And once again you can see every step the algorithm takes. First it tries to go straight, but soon after detects that the target is getting further away, so it tries different routes and ultimately finds the one going in the right direction. I f***ing hate trailers. So let's talk about them. Trailers were a thing I initially thought would take about 2 days of work. Because how hard could it be? It's just an object following another object ahead, right? Well, sure, if the trailer was attached to a spaceship. But alas, it isn't. And we had to deal with so many edge cases, collisions, yielding, lane changes, uneven lane heights and lane tilt, middle connections, and so many little things I have already suppressed in my mind that I almost went crazy. But in the end, we managed to get them to work. Let me show you the results. Also, I would like to add that we were developing and testing everything with 3 trailers attached behind the bus to make our lives unnecessarily hard, but also to ensure that the game will handle multiple long trailers just fine. So I'll be showcasing everything with 3 trailers, but I am gonna drop the bus. First of all, we had to deal with height differences, and as usual, we took it to the extreme on this map. The results are about as expected, but the important thing is that the game can take it. That's right, it better take it after everything it put me through. If I didn't disable pathfinding limits, the track would never attempt to navigate this road anyway. Here's a standard yield so that you see the track is waiting for the other track to clear the intersection completely. Here's a similar scenario, but the intersection is way more acute. This I call the lobotomy loop. While nothing may seem out of the ordinary, we've built it in a way that there are so many edge cases that it was a perfect place to test stuff. So while it seems the tracks have no problem navigating it, remember the sweat, blood and tears it took to get there. So since the trailers just blindly follow the track, let's see what happens at this abomination of lane engineering. By the way, for all examples being shown here, pathfinding limits were disabled, otherwise no track would subject itself to these horrendous conditions. So again, the results are, let's call them satisfactory. So can you see where this is going? Yep. So for obvious reasons, vehicles can't collide with their own trailers. Trailers and lane changes were so complex that they'll need their own chapter in this video. Here you can see a truck cutting across 10 lanes, which is perfectly legal because the minimum length for a lane change is 5 meters on this specific road. It will be editable per road segment, so for example for highways you could increase this limit to like 50 meters per lane change. It's important to add that cutting across multiple lanes is not possible in junctions. Vehicles always change lanes one by one and always respect the limit, which is shown as this red line here. Here's an average 3-trailer truck merge, and here's the same merge but on a way shorter road. Here's how trucks change lanes next to each other. The top one will wait for the bottom one to end its maneuver before attempting its own. This is how it looks when two trucks want to crisscross each other. Once they stop, the one in front starts its lane change first. There will be some clipping, but there's nothing we can do. This is how the same thing looks on a multi-lane road. Now let's imagine it with way more trucks. Looks like everyone passed unscathed, except the programmer. Well, this gave me an idea. Ladies and gentlemen, I present to you the Brexit Simulator 2026, aka the UK-French border on any given moment. We also completely reworked rail vehicles. Remember the tram roller coaster from a few episodes back? Here's a tram with 300 carriages on top of it. You gotta love the feeling of connecting a newly built transport belt to your factory output. Oh yeah, truly a sight to behold for the average public transport enjoyer.
That's a 10.
If you're interested in knowing why junctions got delayed, this right here is one of the reasons. I've already talked about it in the previous devlog, but I need to mention it again. So previously, if you wanted to build lanes like this, you would need to use at least 5 lanes. And this together is a perfect navigation graph because the connections are always at lane endings. But during playtesting, we realized that when people place lanes, they often try to connect them in the middle, like this, which obviously didn't work. So after a bit of deliberating, we decided to add this option. So when you look here, there is one lane, another lane, and the center lane is a single piece. But now, the navigation graph is no longer connected nicely. There's a connection in the middle. This lane ends in the middle of this one, and this lane starts in the middle of this one, which completely ruined everything. Could have, of course, split the center lane in the background without the player even realizing, so that the graph would remain the same, but that would have introduced a lot of new problems. So in the end we decided against it and went on to fix everything that broke. And by everything I mean traffic lights, obstacles, collisions, yielding, pathfinding, and of course trailers. And also trams, but as you can see both road and rail vehicles have no issues navigating these kinds of paths anymore. Also, one of the edge cases of the lobotomy loop shown previously was a cursed middle connection like this. So that's about it. I would like to just add a couple of things. First, every debug tool you've seen in this devlog will be available in the release version. One of the big issues I personally had with other city builders was that there wasn't nearly enough information to determine why something was happening. We will do our best to mitigate this. Second, while I was using the word we throughout this video, the reality is that I had to code everything showcased here by myself. That's why it took so long. Also because I might be a little slow. That being said, it gave my colleagues a lot of time to focus on other features which are now going to be way more robust and polished. Next, the driver behavior showcased here is not final, and we want to add additional features before the early access release, such as reversible lanes, living streets, emergency vehicle priority, parking, and some other minor things. Unfortunately, public transport will likely have to wait after the game releases, because we're running out of time and money. So, because it's been half a year since the last devlog, the AI obviously wasn't the only thing we've been working on during this time. We also worked on a completely new UI. We finished the traffic sign designer, created a circuit network tool, traffic light designer, and face configurator, added a bunch of new 3D models and low poly mode. These will be showcased in future devlogs. Speaking of, one of the reasons why there was such a long break between the last devlogs is, as you might have also noticed, the fact that I dislike doing them. I'd much rather code. So I can't promise how often these are going to be released, but you can rest assured we are working on the game. If you want very frequent updates, feel free to join our Discord where I talk with everyone. The link is in the description. Or, if you'd be okay with smaller and more frequent updates here on YouTube, you can let us know in the comments. Oh, and I almost forgot. Our publisher
asked me not to read this, but god damn it, I'm going to read it anyway, because I wrote it, and it's the truth.
If you've been enjoying these development videos and are looking forward to Junctions, a great way to help is by wishlisting the game on Steam.
Ladies and gentlemen!
In either case, thank you for watching and I'll see you next time. Bye bye!